when you have two vectors and you want the angle between the two vectors, so say you have a vector A and another vector B, the angle between the two vectors you can find using the dot product. So the cosine of the angle is equal to the dot product, or the scalar product of the two vectors, divided by the product of the magnitude of the two vectors, right? So this is how you would find the angle. So in this question, we're given two vectors, A and B, but the k component is missing. So if we call the first x and the second y, x and y are now our unknowns. So if we rewrite x and y in column notation as vectors or as matrices, it would look something like this. 3, 2, negative x. I say negative x because there's a negative in the question. There's a negative sign included there. And b is negative 3, negative 2, and y. Then the dot product of the two matrices will be the product of the I, j, and k components added together. So we take the I components, we multiply them, then we take the j components, we multiply them, and we take the k components and multiply them, and we add those together. So it's 3 times negative 3 plus 2 times negative 2 plus negative x times y. And the answer is given in the question as negative 29. So that's negative 29. So if you rearrange that, that will give you x multiplied by y equals 16. So we can't solve that, but it's useful to know that the product of x and y is 16. So we can save that as an equation that we will then return to later on. So that's equation 1. Let's use the second piece of information given in the question, which is that the angle is 180. And we know we can write the angle in terms of the dot product, or in terms of the scalar product. So it's equal to the dot product, A dot B, divided by the magnitude of A times the magnitude of B. And we know that the dot product, as given in the question, is negative 29. We just need to find the magnitude of A and B. So the magnitude of A is square root of the sum of the square of the I, j, and k components. So it's 3 squared plus 2 squared plus negative x squared, which will give me x squared plus 13. And similarly, the square root of, or the magnitude of b will give me y squared plus square root of 13. So now if we put these into the cosine equation, we can say cosine, and the angle is given as 180, so cosine 180 equals A dot B is given as minus 29. And we put these two in the denominator. So x squared plus 13 times y squared plus 13. So again, we have an equation with two unknowns, x and y. But we can still simplify that. So the cosine of 180 gives you -1. So that seems to me to say that this denominator needs to be 29. So we can say square root of x squared plus 13 times square root of y squared plus 13 equals 29. If we square both sides, that'll give me x squared plus 13 times y squared plus 13 equals 29 squared. Now we can go back to equation 1 that we saved earlier and replace y, for example. We can say y is 16 over x, and then we can insert that or substitute that instead of y. So we'll then have an expression that looks something like this. X squared plus 13 times 16 over x, which is our y, squared plus 13 equals 29 squared. Now we have an equation with a single unknown. So it's a bit cumbersome, but eventually it is solvable. So if I multiply out each of these terms, so I multiply x squared first, and then multiply the 13, eventually I should end up with a value for x, and then I can substitute that into equation 1 to find a value for y. So I'm going to get 16 squared over x squared times x squared plus 13x squared plus 13 times 16 squared over x squared plus 13 squared equals 29 squared. So that simplifies with that. And if you multiply everything by x squared, that'll help to get rid of this x squared in the denominator. So I'll say here, multiply by x squared. So that'll give me 16 squared x squared plus 13x to the power 4 plus 13 times 16 squared. Now this x squared will cancel with this x squared. And I'll have 13x squared equals 29x squared. Now that looks like a lot of x's, but I think eventually it all simplifies. So let's collect like terms. So we've got x squared here, x squared here, and x squared here. So I've got 13x to the power 4 plus x squared into 16 squared plus 13 squared minus 29 squared, which is 0. No, it isn't. It's negative 416. So now I've done all the terms. All that remains is these 13 times 16 squared. So 13 times 16 squared is 3328. So plus 3328 equals 0, because we've brought the 29x squared to the left. So now what you have is a quadratic. You're going to need to change this variable to actually consider it a quadratic. So if you consider x squared to be, I don't know, w, then x to the power 4 will be w squared. So your equation is now 13w squared minus 416w plus 3328 equals 0. So using the quadratic formula, we end up with omega equals, or w, sorry, equals 16. And if we then replace w with x squared, so x squared is 16, so x is plus or minus 4. We can then find y, because from equation 1, y is 16 over x. So that's 16 over positive or negative 4. So that gives you positive or negative 4. So really the solutions are either x is 4 and y is 4, or x is negative 4 and y is negative 4. So that's how you would answer a question like this.